All right, so that was sort of, I wanted to leave it for Sharath if he had any final closing comments, or Glenn if he had any closing comments.
No, but maybe we should just add a couple of those links also in the chat for Maximo Visual Inspection, IBM Edge Application Manager. I also have an article that kind of goes through the process and step by step of how we put together the use case that we showed. So maybe some of those links we can share on the chat, and I'll put
Yeah.
that across. But
Okay.
that's all I had.
There's a couple of things that I think people might be interested in. One is the distinction that we keep saying between IoT devices and edge devices. So what are we talking about when we say that? Because, there's some pretty cool little tiny edge machines like this guy right here. This is an Espressif device called an ESP32, and its predecessor was the ESP8266. These things cost about $1. They have Wi-Fi, Bluetooth low energy, whatever, a 32-bit processor, and you can do lots of great things with them. But they're IoT devices. They're not really able to be edge devices in our in the way that Open Horizon and IEAM look at edge devices. And the reason is they actually have a couple of cores in one of these things, and they can do some interesting things. You can run some of those inferencing algorithms on it, to do visual object detection, but there's no Linux kernel. And that means it's quite limiting in terms of what you can do. You can't have two processes here running on this machine that have independent memory spaces and can't corrupt each other. I mean, you're basically running a single process in here. It can have a couple of threads because there's two cores. But it's pretty limiting. And if you want to try and update this in the field, that's a bit challenging too, because basically you have to carve it in half and have the running software also be able to do the management stuff, and the management stuff writes to the other half of the memory, and then cuts over to this one, which also has the management and the new version of the program in. And to my way of thinking, it's a really good way to brick this device in the field and have your customers very angry. So in contrast with a Linux environment where you can have a quite intelligent agent like our little IEAM agent, it's just a whole different other world, and a lot safer for you and for your customers. And there's another item that I wanted to mention briefly, if we have time still to talk about it, and that's the zero touch part of it. So I made the bold claim that you can just connect your wire and that's it. That's all you have to do. And I have a few slides that I could show to walk you through how we've integrated with the secure device onboarding, which is called SDO, which is a Linux project, a Linux Foundation Edge project, and which is going to, I think, become the FIDO project, FDO project, which is FIDO's version of secure device onboarding. But it's open source. It runs on ARM and it runs on Intel. But let me show you some slides. So I'll share screen again. And hopefully Kevin will catch me and bring me up to the front here. I had some slides on model management system too, but I think you can go and look at the model management system stuff yourself in that playlist. But let's take a look at this guy. So imagine being able to buy diverse edge devices from distributors or retailers, and here are some possible candidates that you could run. Ship them to your remote site. Use UPS to get them to the remote site. Get a local technician to just plug them in, and you need power and network, of course. And I showed power over Ethernet here so that you can have the power and the Ethernet or network in a single wire. But if maybe you have two wires, then have it magically, okay, well, it's not really magic, it's just fully autonomous, but fully autonomously install and configure all the required software. No SSH, no USB key, nothing. No skilled person on site to do your configuration of your device. Would that help your business? Well, with Open Horizon and secure device onboarding, we can do exactly that for both Intel and ARM devices, and you can optionally use a hardware root of trust. So if you have a TPM module, like all Intel devices in the past something like 10 years have TPM hardware, and some ARM, for ARM devices, you can actually add an external hardware root of trust to them. But let's see how it actually works. So when the software is installed at the manufacturer, you install the SDO software. And in conjunction with that, you also create an ownership voucher that matches the hardware identifier in that piece of hardware. And so the voucher and the device with the SDO software, they always go together from then on through the entire distribution chain. So it stays with the device from factory to distributor to end customer. And then when the end customers receive their devices and their vouchers, they load the vouchers into an Open Horizon management hub. And so you saw the web UI of the management hub for IEAM. That's the hub that you would load the vouchers into. And remember, the vouchers are tied to the hardware identifiers in the actual physical devices. So now the management hub knows about those specific pieces of hardware. So when you load their voucher in, you can tell them, I want this software deployment pattern to run on that specific device, or I want this node policy installed on that particular device. And you do that based on the voucher. Then that's all you need to do. And the Open Horizon infrastructure uses the voucher to tell the SDO Rendezvous Server, which is another component of the system, how to install the agent and how to configure it with those pattern or policy. So it shares the voucher information with the Rendezvous Server. Now, the Rendezvous Server, we actually provide one in the management hub that you can use, but companies that manufacture SDO devices, they provide their own Rendezvous servers. So Intel, for example, has their own Rendezvous server, and some of the other companies that we're working with, they're probably going to be setting up their own individual Rendezvous servers because they want to have more control over it for their own company. Then from that point, it's fully automated. Zero touch. Our little robots just take over and manage everything for you. So once the voucher is loaded, the SDO Rendezvous server has been informed, the customer can connect their devices, and the device, the software, SDO software on the device contacts the SDO Rendezvous server. So it has to have access to the Rendezvous server for this part of the setup. Afterwards, it does not need it. And it provides its specific identifier that corresponds to its voucher. And that well-known address can be anywhere. You could run your own Rendezvous server inside your factory, for example, if you wanted it to be fully disconnected from the internet. And then the Rendezvous server will respond with the Open Horizon agent install script and the configuration details that are specific to the role of this specific device. And from that point onward, the Rendezvous server is not required and is never used and never communicated with again. And from then on, it automatically installs and configures the agent for the appropriate hub. And then it includes the Open Horizon credentials, pattern policy, and it interacts with the management hub in the normal way that it would if you configured it manually. Okay, a couple comments on the root of trust. The devices can be manufactured with this, or you can add the SDO capabilities to your own ARM or x86 devices. So for me here, none of my Raspberry Pis or anything have the SDO software installed on them. So I simulate the manufacture of an SDO device by running a little script on the Raspberry Pi that generates a key that it can use as its hardware identifier, only it's actually a software identifier. SDO supports EPID or ECDSA for device attestation. The hardware root of trust can be provided from EPID. Discrete Trusted Platform Module, or TPM, or discrete external hardware element, which is typically what you would use in an ARM device, or an ARM device, an ARM processor with a built-in secure element. Some of the newer ARM processors have that. And then you can use the less secure software root of trust, like a ECDSA private key, stored in the file system of the device. And of course, you have to install the SDO software, client software on the device. And that little script that I said that I run for my own devices, that's what I use here.
There was a question about what a rendezvous server is, and I just dropped in the chat some of the secure device onboarding Git repositories, which Intel does a good job of describing the components.
Yeah, so the rendezvous server is typically provided by the manufacturer of the SDO device. But if you're rolling your own, you're simulating the manufacturer of an SDO device, like I do right here in my home office, then you can just use the one that's built into the management hub. So every management hub, even the little development one that I use in my home here, has a rendezvous server built into it. And so that's the easiest thing. And actually, to be honest with you, I sometimes just use the Intel one, because it doesn't matter, right? I mean, the Intel one accepts the voucher information, as they say, promiscuously, right? It doesn't care who is talking to it. So you can use, anybody can use the Intel SDO rendezvous server. And the same goes, I guess, for the one in my house here, except I have it firewalled off from the internet. But any device in my home could reach out and start talking to the rendezvous server in my house.
Very cool. Okay, I think we're going to call it a wrap here. I wanted to thank our audience for joining us today. Enjoy the rest of the Think conference. They've got a great set of main stage presentations. I wish we were in person. Hopefully next year we'll come together again. But do join us tomorrow if you're interested in getting some hands-on with IBM Edge Application Manager. We've got a lab. You can join Glen and I again. And that's tomorrow afternoon Eastern. We're going to do this as a replay for our colleagues in Asia Pacific. I think that's on their cycle. But really delighted that you were able to join us at the conference today. Wanted to thank my panelists. It was great to have Glen. It was great to have Sharath join us. And be safe, everyone. Wear a mask.
So one thing, if you wanted to reach out and contact us, I'm happy to offer my email address, which is Glen Darling, Glen, single N, Darling, at usibm.com. But I'd much prefer if you contact me on the LFEdge Slack. So if you join lfedge.slack.com, and you can send a message to Mosquito. I'm at @Mosquito on the LFEdge Slack. And I participate in many of the working groups on that Slack as well, so you can contact me there. So.
Cool. Thanks, everyone. All right, we'll sign off here.